Here we are discussing an important question from the chapter Relations and Functions. Question is basically based on the topic functions. Here question is, show that the function f defined from set of natural number n to set of integers z defined by fn is equal to half of n minus 1 when n is odd, and fn is equal to minus half into n when n is even. We have to show that this function is both 1 and onto function. As we have discussed in the previous videos also, that a function is said to be 1 function if for distinct elements in domain you will get distinct images in the range or codomain. Okay, means if images are distinct, then elements in domain should also be distinct, then it will be 1. So let us see solution here. First of all, we will show that this given function is 1. Correct. So let us suppose that x1 and x2 belong to set of natural number and x1 and x2 are odd, because two cases are here, odd and even, so we have to discuss separately. Correct. So therefore f of x1 is equal to f of x2. If these two images are equal, then we need to show that pre-images will also be equal. Okay, so x1 and x2 are natural number as well as x1 and x2 are odd numbers. So we have to apply this definition of the function for odd natural numbers. Okay, so this implies that f(x1) is equal to, from this given definition, half of x1 minus 1 is equal to half of x2 minus 1. Half of x2 minus 1. Half will be cancelled out. Sorry, minus 1 will be here. Okay, minus 1. Minus 1 will also be cancelled out. So we are getting here x1 is equal to x2. So as fx1 is equal to fx2 implies x1 is equal to x2, this function is 1 function. F is 1. Similarly, we can show that if natural numbers are even, in that case also we will get the same condition. fx1 is equal to fx2 implies x1 is equal to x2. Simply, what will be the change in that step? Simply, in place of odd, you have to write even. x1 and x2 are even, and we have to follow the same process and we will get the same result. So in both the cases, when natural numbers are even or odd, in both the cases this given function is 1 function. So we have to show this step once again, simply replacing here this word odd by even, and we can write the conclusion that here function f is 1 for odd and even n. So this first part has been proved. Now we have to this one, so this one onto second part. Correct. Let n belongs to set of natural number and n is even. If n is even, then naturally, we'll be starting with odd. Correct, is odd. So if n is odd, this implies that 2n plus 1 is If n is odd, then 2n plus 1 is also odd, because 2n is always even and even plus 1 is odd, correct? So if 2n plus 1 is odd, therefore f of 2n plus 1 is equal to, using this definition, this will be half of n, means 2n plus 1 minus 1. Let us simplify it. Here plus 1 minus 1 will be cancelled out. So this is half of 2n, 2 will be cancelled out. This is equal to n. Similarly, let n belongs to set of natural number and n is even, correct? So if n is even, this implies 2n is even, and this implies minus 2n is even. So here f of minus 2n is equal to, we will use this part of the definition, minus half into minus 2n. 2 will be cancelled out. This is equal to n. So in both the cases, whether n is odd or n is even, in both the cases we are finding that if n is odd or n is even in codomain or in range, then we are getting pre-images here in domain. With respect to this n, when n is odd, we are getting 2n plus 1 as the pre-image in domain, and if n is even, then with respect to this n belonging to, yes, yeah, codomain, we are getting minus 2n as the pre-image. Okay, so here we can write as for every n belonging to codomain, so for every n odd or even natural number, we are getting pre-images in domain. So therefore f is onto. Therefore f is onto. So we are proving here that f is 1 1, and we are proving here that f is onto. So therefore f is 1 1 and onto. It has been proved here. Very interesting. Hope you have understood it. Very important question. Okay, so remain in touch with these videos. We have to discuss some more important questions, and please subscribe this channel if you have not subscribed yet. I need your cooperation, and please share this video with your friends also. And if you have any doubt, any problem, please write in the comment box. I will definitely address it. And if you are enjoying these videos, getting benefit from it, your likes are most welcome. Wish you all the best.